record this. All right, great. Thank you for joining us. Welcome to Exchanging Ideas 34, Global 5G Evolution. Please take a couple of seconds to click the subscribe button on our YouTube channel. I'm Kaneshwaran Gondasamy, and I'm the founder of Global 5G Evolution. And we, Global 5G Evolution, built global 5G community. We have reached almost 280 5G experts around the world. And we have reached almost 52 countries with the 5G ecosystem experts coming from MNOs, research institutes, SIs, towercos, startups, software as a service companies, market research companies, enterprises, metaverse providers, AR, VR provider, university research, startup accelerators, hyperscalers, vendors, satellite providers, NGOs, and 5G labs. We encourage your organization to raise this global 5G community program to strengthen the local 5G communities by embracing the world best practices for deploying 5G network and ecosystem services and applications. Global 5G Evolution, able to power your 5G community strategies for driving innovation and progress in the field of 5G ecosystem. All right, so now we would like to accelerate the 5G adoption in the industries and enterprises, and global 5G evolution able to bring benefits in terms of inviting international industry experts to speak at your events. And we encourage member participations into forums, blogs, and interactive sessions. And we are a tool that can help you and your organization to learn more about 5G use cases and models. And we also do conduct mentorship program that can help experienced members with those who are newer to the field and looking for guidance. Global 5G communities in numbers, we have done 40 in-depth conferences with 30 of one-to-one webinars that we post in our Facebook page. We ourselves have over 10K followers on our LinkedIn with 1.8 million impressions in 2022. We have about 2,000 subscribers on our YouTube channel. We had about 191 organizations have actually joined in our programs with 5 industry partnerships, representation from 51 countries. We have hosted about more than 500 case studies from the international organizations, associations, vendors, mobile network operators, and we are trying to aim to close down one National 5G Alliance ecosystem this year. As you can see, these are the vendors, SI, metaverse providers, AR, VR providers, towercos, hyperscalers, market researchers, startups, enterprise, 5G labs that have actually joined us. And we encourage diversity and inclusion, and you can see there's a huge diversity in terms of young master students, experts who have joined in our program. And most of them have thanked me because they have got a job by speaking in our program. And we see a lot of mid-level managers and senior managers. We also see C-levels also have participated in our program. And please do subscribe our YouTube channel by scanning this QR code. So when it comes to the telco industry landscape changing, we can able to see challenges in terms of declining revenues of core services. And we see there's tough competition with hyperscalers and OTT, and there's a rise of private 5G and the spectrum allocations, right? So our ambition is to enable the set of digital service offerings. We can see a lot more tuned bundles and products to enterprises, and we can see there's a lot of digitalizing customer engagement models as well. So as you know, the 5G era service providers are moving from the traditional of 3G, 4G voice and message and data towards to a bigger landscape of 5G edge computing service provider, IoT, private network, vertical players, cloud gaming, AR, VR, metaverse, and media entertainment. And there's a lot more developers, startups who are venturing into the areas of moving object entertainment, production, and other areas in security, financial, healthcare, agriculture as well. So the non-telco industry landscape, you can see, is very much to the national mobile operators, but it's moving towards to a bigger landscape of vertical transport, port, airports, decentralized MNOs, city councils who wants to play a bigger role in the 5G service as well. We have conducted a lot more of global 5G community activities last year. We have partnered with few 5G labs. We are moving towards the virtual 5G labs. We are offering for researchers, developers, as they provide a flexible and cost-effective way to test and experiment with new applications. And we want to foster more collaborations and knowledge sharing with the 5G community. So we are also trying to build a network of local chapters in different cities or regions, starting from Malaysia and Southeast Asia. And this can help to reach a wider audience and collaboration as well. And as you see, there's a lot of activities that has been done in 2022 and 2021 as well. In terms of the Gen Z, we are trying to give awareness to more the younger generation, because the younger generation are moving towards more to the digital nomads. They don't believe in the digital or in the degree programs or master programs. Right after the O levels or A levels, they want to actually travel all around the world and see how they can able to work remotely. And I think there's a lot of more changes that's happening to the Gen Z, and we can see a future ready workforce who wants to work remotely with building up their own skills. And that's where the 5G virtual labs and the telco cloud skill helps will be able to help to the niche Gen Z. And we are trying to see to build the 5G Young Talent Community series. In this year, we would like to create more partnership with the startup accelerators to the young tech communities, and how we can help them to come up with their startups by sharing the knowledge of 5G and its ecosystems, and also support the startup incubator programs as well, right? We also want to encourage the youngsters to join us in the speaker series programs as well. And we want them to be more confident in their domain of expertise as well. And we would love to give the avenue to test their 5G applications as well. And we can see the benchmarking from the pay scale. We can realize that, this is benchmark to the Malaysian salary. As you can see, salary 1.0. We can see there's a huge, enormous of paid that applicable to the technology positions compared to the managerial positions or even C-levels. So we know there's a need of skill sets, and there's a highly paid in the countries like, for example, in US or even in Singapore or Qatar or even Australia as well. So there's huge, enormous of need skill sets in the technology position as well. So this will be my last slide, and I just want to share you in terms of the global 5G community series that I'm handling. We will kickstart in the Young Talents program this year, and we want to have more young talent to reach out to our network organizations as well. We also trying to create more activities in the lab, tests, trials, and demos as well. And we want to see how we can partnership with the youngsters communities and alliance, and we want to see more innovations in terms of the use cases, particularly for the 5G domain as well. So this is overall on the my presentation, and let me introduce to the next speaker. I would like to introduce Nilupul Navan Sinaviratna from Tokyo, Japan, to present on the 5G UAV unmanned aerial vehicle. Over to
Yes.
you.
Thank you. And have a nice day. Thank you, Mr. Kaneshwaran Govindasamy, for inviting us this great session and exchanging ideas on global 5G evolution. So today, I hope to discuss about the impact of 5G technology on unmanned aerial vehicle, commonly known as UAVs. I'm Nilpul Nuwansena Viratna from Shibaura Institute of Technology, Tokyo, Japan. And I'm a research and a teaching assistant here at Image Processing and Robotics Laboratory. And here we are doing some interesting researches based on flying robotics, like UAVs and other drones. So I hope this presentation will inspire you to explore to the possibilities of 5G UAVs and their impact on various industries and application. Okay, let's get started. And unmanned aerial vehicle or UAVs and have come a long way in recent years, and from a military application to commercial use. UAVs are transforming various industries and improving our life in numerous ways. With the introduction of 5G technology, the potential of UAVs has become even greater. We can explore the benefits of 5G for UAVs and it impacts on different industries and applications. And also we will examine the increased bandwidth and low latency we know provided by 5G networks, and how this making UAVs more efficient, safe, effective, and various industrial application. And we will also address the challenges and consideration that come with the implementation of 5G technology on a UAV, and how this can be increased to ensure safe and efficient deployment of 5G UAVs. So let's dive the exciting world of 5G and unmanned aerial vehicle. So okay, what are the benefits? We will take a closer look at the numerous benefits of 5G technology for UAVs. First, 5G network provide increased bandwidth and low latency compared to the previous generation we know, and this improved connectivity allows the UAV to operate more efficiently and effectively even in challenging condition like natural disaster. And next, real-time communication capability of 5G network provide greater control over the UAV operation, like reducing risk of the accident and failure. And this improved safety makes 5G UAVs ideal to critical missions such as rescue operation, industrial inspection, and disaster relief efforts, so on. And increase this speed of 5G enable UAVs to carry out complex operation and mission in real time. And this improved performance can lead to increased efficiency and low cost saving for various industrial application. Finally, this combination 5G and UAV technology is enabling new application and some user cases, and some kind of delivery services and aerial mapping, agriculture to construction. Actually, the possibilities are truly endless, and just we are scratching on the surface what 5G UAVs can achieve. So application of the UAVs with 5G. First, increased efficiency and safety provide the 5G UAVs are making them ideal for various industrial applications, such as inspection and maintain pipelines, power lines, and wind turbines, and telephone tower. And the improved connectivity and speed of 5G networks also allow to UAV to collect collect and process data in real time, and enabling them to make more informed decision and carry out complex tasks. And 5G also transforming the delivery industry, also in agriculture sector. UAV are enabling farmers to collect more detailed on crops and soil and weather condition. This information can be used to make more good decision on planting, fertilizing, and harvesting to increased their efficiency and productivity of the farmland. And also we can expect even more exciting application and user cases in near future. And this is one of our research, and I contributed with Mia University and Shibaura University and my home university, Goembe University of Sri Lanka. We did some Pikmin people survival purpose based on using image processing, especially in thermal image processing, some kind of drone based project. We used in 2019, we used 4G technology, but we can improve this kind of researches more efficiently with 5G technology. And what are the challenges and consideration? We will address the challenges and consideration that come with the implementation 5G technology on a UAV aircraft. And we know first cybersecurity. Cybersecurity is a major concern. As UAV collect, transmit, and sensitive information like video transmission and image transmission, sensitive information and data. Ensure the security of the data is critical, and measures must be taken to protect it from the cyber threat and attacks. And next, another thing is spectrum management is a challenge, because they must be addressed to ensure the safe and efficient deployment of 5G UAVs. The increased bandwidth and low latency of 5G networks required, adaptive spectrum resources, and carefully planning is needed to ensure that UAV can communicate effectively with the ground-based network, because we know usually we are using some kind of brushless motor, create some more radio waves and something. We need to protect them. Then finally, regulation and standards important to consideration, and as they play a critical role in ensuring the safety, efficient deployment of 5G on UAVs. Especially in Japan, there are so many restrictions for the UAVs and drones, and also for the wireless communication. Sometimes we are in some kind of research, we need to go to another country to test our research. Tokyo, outdoor flying is prohibited usually in Tokyo. And also this is the I have attached some nearest 5G supported drone platform. This is the existing one called Navio 2. We know every UAV has a brain. This kind of drone has a brain. It's called flight controller, and this is a Navio 2 product of the EM lead company. Recently we are using this kind of board, and it came with some it need Raspberry Pi single board computer, so we can provide easily 5G network to this part. then we can control using through the 5G network. Also, this is a very recent one. Qualcomm company. It's very famous in the chip maker, SoC, system on chips maker. And they recently launched this Flight RB5 5G platform. It's a usual drone, but it has so much good hardware environment to connect with 5G network and run AI, ROS, and another Ubuntu Linux platforms. And also, this is another one, Yarlink 5G unit. I think it's a product of a Skydrone company in China, and there are so much interesting specifications. And finally, the combination of 5G and UAV has the potential to revolutionize numerous industries and application. The benefit of UAVs and including increase the efficiency, safety, and performance are truly game changing. And can expect to see continuously growth, I think, in innovation in this field. And in near future, we can able to process data in lively in UAVs using artificial intelligence, and also hardware parts, including drone, which we are using to processing, we can be reduced because the data can be processed on a cloud easily. We have more powerful cloud processing AI platform, so we can combine that both of them. Then we can reduce the hardware side and power consumption of the UAV. In a conclusion, 5G UAV represent a major step forward in the revolution of unmanned aerial vehicle. And I hope this presentation provides some valuable insights into the potential of 5G for unmanned aerial vehicle. And time is limited, and this is the end of my discussion. Thank you for your attention.
Thank you, Nilupul. You nailed it. Brilliant presentation. I appreciate that. Now, moving on to the next speaker, let me introduce Ahmad Matses from Jakarta, Indonesia, to speak on 4G to 5G RAN smooth transition. Over to you, Ahmad. Are you there, Ahmad?
Okay. Thank you, Kani. Sorry, I just joined. So I think it's very interested that this is my second time to join this 5G. Wait a moment. 5G sharing idea. So allow me to share some update and what we have done in Telkomsel in order to deliver 4G to 5G smooth transition. Even at the time in Indonesia, the current implementation for 5G still not massive yet. So there are 4 points that actually I will convey during this sharing. First is related to Telkomsel, and then what is the 5G trend worldwide, and then we will share what happened in the Indonesia, especially in Telkomsel, and the next what is the challenging for the 5G implementation. So just to share that Telkomsel is the biggest operator in Indonesia, that currently we have around 160 million customer. And then until now we have implement 5G since 2 years ago. So, but the current implementation still not quite massive. So there are 3 pillars that actually we provide in Telkomsel. First is related to how to deliver digital connectivity, and then we have digital platform as well digital service in order also to support digital transformation in Indonesia. And that just like I mentioned, just to highlight what I mean the trend for 5G worldwide adoption, that until now there are around 235 network that already live worldwide, and then the SI itself, the implementation is around 35 network, and then I think the trend also for the 5G deployment even quite massive, but the trend right now I think become quite stable, because I think still very challenging with the business case. So the current population is that already covered by 5G around 32%, and then mobile data consumption I think around 29%, and I think this is all still not too big compared with the 4G. And then if we look the forecast that mostly the device that shipment is already 5G ready. So we expect that the trend will continue growth that we forecast that around in the long term around 79% in 2026. While for 5G subscription forecast itself, we can see the currently around 4.4 billion customer that already become like 5G subscriber, and then I think the trend will increase significantly. And then if we talk about the Indonesia, especially like for Telkomsel, that we just highlight that currently we already implement in the 49 cities, but still limited in the some cluster and hotspot area with around more than 300 INOT B. And then our 4G device that detect in our network is around 4 million customer. And then if we look to the spectrum, what is challenge? What is the current spectrum that we use for 5G in Indonesia is mostly still refarming the current spectrum that we use for 4G. So I think this is also that make the implementation not really massive in Indonesia. So for Telkomsel use case, that the current we use for 5G is 2.1 and 2.3 gigahertz. So in the like I mentioned, what is how we implement the 5G? So in the beginning, for first implementation, we use 2.3 gigahertz for the 5G. So at the time, there are only I think 2 operators that already implement. First is Optus, and then other operator I think in the it's Middle East. But during the implementation, the device ecosystem is quite challenging. So not all the handset device is support the spectrum 2.3. That's why we changed the strategy that we start the implementation 5G in our network using the SS dynamic spectrum sharing 2.1 gigahertz. And then in terms of device, mostly the handset that available in the market is support the spectrum. And then if we also compare with our investment, it become more efficient, because we can implement 5G using our existing 4G network. So what we did, we we upgrade the current network, the RRU from the 2T to R to 44R in order to deliver better 5G experience. As well, actually in this year, we also have additional spectrum in the 2.1 gigahertz. So the total spectrum that we have right now is 20 megahertz. So I think it's very powerful when you use dynamic spectrum sharing between 4G and 5G. And also it's very good in terms also in OPEX because there is no need additional RRU and also increment the power in the related to the electricity. And then this is just to share how our journey related to the 4G innovation that since we launching in the 2021, and then we continue to implement some 5G use case like during MotoGP in Mandalika that Telkomsel can deliver the speed until 5 gigabit per second. That this is using the massive MIMO, the millimeter wave spectrum that actually still not official from government. And then in the we continue 5G source case in order to support the industry. And then we also implement the first 5G underground smart mining in South Asia. So in the Freeport, we implement the smart mining using 5G. And then Telkomsel continue to implement 5G during the G20 event in Bali. So we provide best network as well using 5G during the G20. And then what is the challenge, I think, for the next 5G implementation? First, related to the device capability, as I mentioned that especially like the spectrum that we use 2.3 gigahertz is not all device support the spectrum. And then related to the spectrum readiness, so actually we are waiting the new spectrum for 5G like 700 that currently ongoing clearance by government. And then we also hope that 2.6 or 3.5 gigahertz can be allocated soon by government, including the millimeter wave. Is also what is the challenge for us because we just implement in the cluster basis. So there are still issue with coverage limitation. So the customer still didn't feel full experience when they use the 5G, including that we need to ensure the readiness for infrastructure itself, both tower and transport, because mostly we need to conduct upgrade capacity, especially in the transport. Last but not least, actually the big challenge is related to the limited 5G use case itself. So like for B2C, I think this is something that until now challenging for 5G, especially in Indonesia. Why is not massive implementation? Because what is the requirement for B2C user 4G network? So I think this is that we need to continue what the killer application or use case, especially 5G in the B2C. While for B2B, we still continue working together with industry, because I think this is also like chicken and egg, because we need to convince the industry that we implement the 5G itself, what kind of gain that will get in terms like automation, in terms of cost saving. So what we see that we continue to implement 5G, but not aggressively. We still see what is the market response, because we know that implement 5G is also like impact to our cost. So we really careful implement the 5G. I think that's all that I can share from Indonesian market, Kanis. Thank you for the time.
This is so informative, Ahmad. Thank you so much. I really appreciate that. Moving on to the next speaker, let me introduce Anuradha Ulunuwara from Colombo, Sri Lanka to present on 5G transport network requirements. Over to you.
Thank you, Kanish. I hope you can see my slides.
Yes, sir.
All right. So I'm trying to bring in the perspective of 5G transport network requirements. Usually, when it comes to 5G, I think the transport network part is something that we often tend to neglect. So let me bring in some perspectives as to what sort of areas that we really need to be concerned, especially as mobile operators, service providers, network operators, and telcos in terms of supporting 5G in the transport network. So when it comes to transport, we usually have different areas. In the historical context, we just had the backhaul. Now we have front haul, mid haul, backhaul, and different areas that really need to transport our bits. As the 5G becomes more cloud native and disaggregated, modular, and based on open architectures, we see most of the software components and even the hardware components are disaggregated and pushed to different locations based on the service provider's requirement. So that leaves different spaces in between those components which really need transport back and forth. Maybe your media, maybe your signaling, maybe your control signals, etc. Now, what really drives the requirements for a 5G network is mainly actually stipulated by what 5G as a standard or a technology or a concept is actually trying to sell. For example, if you take 5G, for some is all about the high bandwidths, high throughputs, high peak data rates. And on the other side, it's about, I think the previous speakers mentioned about the low latency, ultra reliable low latency type of communication. And then we have the type of densities that you try to achieve, like so many users trying to connect in one specific area. So what a transport network try to achieve, or rather support in terms of 5G, is actually to address all these capabilities that 5G ultimately tries to deliver to the end customer. So in that aspect, I'm not trying to give you the full thing about the transport network, but rather give you some pointers, given the time, give you some areas that service providers and operators need to be concerned of. One is the architecture, where we predominantly see a trend that the combination of IP and the optical, the DWDM architectures, whether you are going to use an overlay type of network, IP overlay on DWDM, or try to bring in the DWDM capabilities to the traditional routers like pluggable optics, or try to use a combination of that. And we cannot neglect the importance of the optical transport network. Although we say 5G and to a great extent 4G is end-to-end IP, we often think the transport network is just the IP transport network. But to support the capacities and the other requirements, we often rely on an optical network to support the IP network and then the 5G services. So you can use OTN, optical transport network, together with DWDM ROADMs, for example. There's a debate whether you should go for OTN framing or OTN switching or both. It depends on multiple things like, for example, sub-lambda grooming and layer 1 protection like layer 1 ASON. But it depends on the requirements of the service provider and the type of capacities you really need to transport to support 5G, not just 5G, but other services too. In terms of protection, the network level protection and also the node level protection, you can rely on the IP layer to provide you the protection. For example, TILFA or the topology independent loop-free alternate, which really achieves something like 50 millisecond protection for traffic. Or can we use optical network, the traditional electrical ASON on an optical ASON to provide optical level protection? Or should we combine both to achieve a different level of protection? And then about one thing about different services supported on the 5G, like network slicing. Should we go for hardware-based network slicing or software-based network slicing, or a mix of that? And this really drives to the side of network programmability, where we really need to abstract network capabilities onto software and try to bring in capabilities or the concepts like software-defined networking and network functions, virtualization, cloud, etc. And last but not the least, we also need to look at the timing or the synchronization aspect of transport network. So different spectrum are allocated for different purposes, like FDD, DDD type of spectrum allocation. And then 5G new radio timing dependencies on satellite-based timing or network-based timing, protocols like PTP and SYNCI to carry this timing information across the network. And also to in terms of standardization, we have certain ITU standards for frequency and time distribution across the network. And we also see certain protocol shifts happening in this migration as well. So we have different protocols for transport or the path type of protocols, and then we have service level protocols, we have configuration protocols, and then we have management protocols. So we see a huge shift, mainly driven by the 5G and newer services. The IGPs are moving from OSPF to ISIS to SRMPLS to SRv6 type of transport protocols, and SRTE traffic engineering, and IGP moving to IGP, LDP, RSVP type of communication moving to ISIS based IGP and SRMPLS v6 type of transport protocols. And services are moving from to a more homogeneous Ethernet VPN plus multi-protocol BGP type of control to support layer 2, layer 3, and all sort of network services which need to support 5G services on top of that. And configuring protocols or configuration protocols from SNMP, MIB, CLI, the traditional way of things, are now moving to more of a template-based configuration of different network devices, including the RAN side, the transport side, and the core side, using technologies like NetConf and YANG. And on the management side, again, we are seeing most of a telemetry type management being introduced to support these things. And if you really look at the full stack, mind you, this is not the IT or the software full stack that we often get to hear, but this is the stack from the transport layer to service orchestration layer in a more summarized way of looking at it. We have the data plane, and then abstracted control plane functionalities. We have network orchestration, and top we have service orchestration. Now 5G in this architecture is more a service, so we need to orchestrate. The 5G service is end-to-end, so you need to orchestrate the 5G service end-to-end. But if you really look at, we see that orchestration is more of an operation support system for the network, although network supports certain parameters, KPIs, which are really necessary for the end-to-end 5G network or rather 5G service to be realized. And then underneath we have everything software defined networks. We have another split, which is the split between hardware and software. We often see that the dependencies or the 5G capabilities are now actually shifting from hardware to software. So we have control plane, network orchestration, service orchestration. Sometimes you can combine the service and network orchestration together, but still there's a massive shift from your focus from hardware to software. And we really depend on telco softwareization, the whole concept of softwareization, which includes SDN, NFV, cloud, and cloud native stuff to support these type of network architectures. So in summary, transport network is a critical part of the overall 5G architecture. 5G is end-to-end IP and also cloud native, and the transport network inherently need to support cloud native type of requirements like elasticity. So network programmability is not an option, it's a must to support 5G and future 6G services. 5G transport network design needs new approaches. You cannot really depend on the historical approaches of network designing. And everything comes at a cost, including transport networks. So you have to be careful about how you prioritize your investment for different network capabilities and to support all these agile and flexible services on the network side. So that's it from my side. I hope that helps. Thank you very much.
That was excellent. Thank you, Anu. Really appreciate that. Moving on, let me introduce to the next speaker. I would like to introduce Rita Nital from Atlanta, USA, to present on the 5G mobile edge computing. Over to you, Rita.
Good evening, Kanesh.
Good evening.
How are you?
Good, fantastic.
Thank you for this session and a warm hello to all my co-speakers. And in a second, I'll just get the full screen here. Okay, I think I figured. Is it good?
Yes.
All right. Okay. So today my topic is multi-access edge computing. As we all know, it is one of the most fun topic of 5G. This is a little bit of the agenda, but before I go into the topic, I just want to say that I believe that, community really inspires the innovation in technology. And so if I look at edge technology as a layman and finding around, I see that, we already live in the edge-enabled society. By that, I mean that what can be more real than life? So today, if we look around, we already have the daily edge use case, and medical is one of the most important use case. So today, if we see the urgent care concept is really around the fast access and the quality of experience in terms of the medical facilities to people in their communities, and it's cost effective, and it's to the point, which is the low latency, because life needs the most low latency use case, which is the Medicare. In this case, if we try to associate the concept itself, urgent care is actually local to the residentials, closer to the local zip codes. You can call it urgent care, you can call it quick access, or the Mayo clinics, anything, as you prefer. But the idea is really the access point is closer to the user, and that's how the service is delivered in the community. But now when we come back to the technology side of it, as we're fast pacing, then we also need to see that what are the real use cases in the mobility world. Let's see what MEC really means literally. So it is the multi-access or mobile edge computing technology. Today we call it interchangeably. But what are the focal points? I think the computing power, which means the real data processing time is very low, increased bandwidth, which is like about the quality, enhanced security because all the private information which is into the network comes to the edge, caching of the data so that the fast access can happen, improve user experience is the deal of the matter, and the cost efficiency as well, because then as it's closer to the edge, then more use cases can be developed and there can be good revenue use cases. Why we are talking of MEC and 5G today, right? Why, only 5G? So the MEC concept is not new to 5G. MEC is already around us for a while. I mean, it could have been implemented in 4G as well, and there are cases. But the 4G network, as we know, holistically, it is little coupled. And, there are point-to-point protocols in that, which makes the network little tightly coupled to implement any new use cases on the fly, especially the edge use cases. In the earlier world of 4G, more cases were developed, but that was customized for the applications. And then operator had to really look into the modular creations of those particular deployments, I would say. But 5G, why 5G? Because 5G inherently, it is service-based architecture. It is a producer-consumer relationship for all network elements. It's open to interaction. It breaks the point-to-point paradigm, and which is the most important point why 5G is really taking over all the type of use cases, and edge is the prominent one. 5G is agile, it's scalable, we all know that. It's cloud native, which is, making it move fast. Now, location awareness and traffic steering control is the new thing, which is giving operators a better control to implement edge, because it's really about having the moving information of the subscriber, and operator can also participate equally more than 4G, because now the network elements have the API model where, any application, any third party can come in and access the capabilities of network, of course, with the API model and, whatever gotchas come with it. And in this model, two major network elements that are used in 5G are UPF and NEF. UPF is to the user plane, as the name goes. It is the user plane function, and it is closer to the user, to the data network, to actually render the service. But along with that, in the background, there are so many other open parameters like DNN, slice info, AF identifiers, and so on and so forth that helps in the traffic steering, because edge is all about traffic steering. How do I take the subscriber to the closest point of delivery? That is the crux of the matter for the edge. And for steering, there are a lot of internal protocols and internal subscriber attributes that are utilized by the operator. And NEF also helps a lot in MEC because it is the exposure function, which is very new in the 5G. It allows all third parties to get a peek into the capabilities and then, create a model along with the operator. So it's no more a silo, but it's little collaborative in that sense. Also, the slice has the session and service continuity type of model where you can have the continued session through the wherever the subscriber moves, and that does a lot in the edge. And of course, it's a revenue type of silver line for operator. Why the slicing in the MEC? Because slicing is definitely bringing out the best of the best in the technology as of today. Slicing, as we all know, it's about end-to-end delivery time and delivery services with efficiency. And not only that, slicing inherently achieves the low latency goals, which are the edge goals, because slice has the property of creating the traffic type resource lanes, and in which already you are having the private lane for the traffic type. And on top of that, when edge is deployed, it becomes like, the double capacity in the sense of giving the edge service to the subscriber and achieving the low latency, which is the point for edge above anything. So MEC and 3GPP, I think 3GPP is doing a lot for 5G. We all know as the release progresses. It has started from release 15. And for Mac, 3GPP has given a couple of phases. I think it started in release 14, but with 5G, I think it is giving more from the 15 perspective. As you can see, I just wanted to see what all the highlight points for the Mac and 3GPP. So architecture and services and performance type of activities really happened around release 15. And then as we progressed to 16, we got industrial IoT, critical applications, and integration with core network, which is very important because Edge itself is a network in its own, and we have to integrate with the core network to bring the best of both the worlds. And then in release 17, they are going more complex and advanced with private networks, automotives, emergency services, and also talking the 6G. So let's see what we do next in 18. What are my use cases? Of course, the prominent areas for Mac also aligns with the 5G pillar use cases, which is the enhanced broadband. So type of use cases would be video streaming, like you are in the stadium and you get the high speed, but it is really, you get the edge type of use case because the video you're streaming could be sitting at the edge and that gives you the best experience. Rural area connectivity. They can be local edge servers which are very close to the rural areas. Today, rural is not connected well, but with the fixed wireless and all those kind of technology where we try to mix and match, this can be very, very important because everything is delivered at the edge. Sponsor data, enterprise traffic, you are having your small enterprise and you want college campus, you want to give certain type of experience to the students, and all that can happen. Reliable and low latency URLCC use cases, augmented reality, which is the truth of today, like e-conferences and the medical remote surgeries and autonomous vehicles and vehicle to conversation to other vehicles on the road. And so much has to happen really real time. So for that, there is no time to actually let the subscriber data travel through the network and get the experience in that type of low latency, which 5G promises, which is sub 1 millisecond, right? MMTC, of course, we all know about all the industrial IoT, smart metering, agriculture, life, and any kind of monitoring which is happening, which really needs the lot of capacity, may not be the latency, but still, if it is delivered at the edge, a lot of analytics can happen at the edge itself and can save situations, especially in agriculture and metering of the transport and the field type of use cases. And recently, I think Canada had one of the use case very smartly implemented where they had the meters for the fuel. So, they can gauge how much fuel is left into the reservoirs and, they can replenish it based on the smart meters. Okay, and then what's in the Max, it's about the deployment. So there's no right or wrong way. It's a decision of the operator, how they really want to keep parameters inclusive, because end of the day, it's all about cost effectiveness and also delivering the best of the technology. So the couple of factors would be cost effectiveness, timeliness, low latency, high bandwidth security, and also the factor that come into the play, as my other co-speaker was saying, the transport, which is very important, right? So radio transport core has to be coordinated. Distributed versus centralized deployments are a lot in the talk today because not everything, it's not a one fit all type of thing. You have to see whether it's the edge or the core, or it's a mix of also. Everything is operator based, and end-to-end network orchestration, monitoring, fault management, automation, and a lot of this basically, it's not anymore the preset, it's more of a palette. So you just pick and choose and make your own way through the edge use cases. Who can create edge use cases? There are two types of edge use cases, operator driven, because 5G gives this really, it's the facility for the operator where the infrastructure is so well designed and so agile that operator can participate more and look into deep dive traffic steering and guiding PDU session type of cases where the routing really happens more in the internal of the core network, and then the UPF and the other network elements can sit at the edge and do the deployment. It can be traditional way of application driven way, like, the edge distributed content servers, which is more traditional, has happened in the past as well. You have the content server sitting, but it's very fixed and type of, as I said in the starting, it's more of a very particular type of use case to be implemented. It's not agile, it's not fast moving, but it can be done as well. What type of effort? I was just trying to evaluate, like if an operator has to do this or a reseller has to do this, it is definitely a big effort, because then you have to really create the edge network and play around your core network elements to see what sits at the edge versus at the center, and still gives the experience with security and everything around. Third-party applications can still go on, and of course they can connect to 5G via NEF, which is the network exposure. The biggest of everything that brings in 5G is NEF, because it is also giving the third party and the application type of servers and the players in the market to talk to 5G. At the same time, it is bringing operator inclusive for the first time. So yes, so that's how, you know, the effort can vary. Why is it popular? Of course, 5G has made it more popular because of the agility, its inherent SD and NFV type of technologies it's using. It's the open bus architecture. The API model has really given the whole new face to this edge type of networking. Is the vision of low latency, which comes without saying. When we say 5G, we know it is about low latency. It is about capacity, high bandwidth, and the traffic lanes with the slicing. NEF, as I said, it is best for the third parties, and that's where most of the, I think, technology experts are looking into and finding what the use cases can be implemented and making it a win-win for all. And as I said, UPF is the hero of this edge services, and it is the delivery point, and it is the connection point for the core network. We can definitely bring in more network elements into the edge network. Time in the world of technology is low latency. It is quantifiable and enriched self-moving resource that is the pivot point of all mobile experiences in all forms. 5G is the vehicle, and edge is the inclusive vehicle that includes the spectrum of general mobility to augmented reality. It's a wide spectrum to see how the use cases vary and how, you know, we balance out all the parameters of 5G. 5G Edge is definitely a community dream for bringing the connectivity to global south, to the rurals, and to bring the community inclusive. And for operator, definitely it has the potential for shorter time to market, additional revenues, onboarding new market, proximities, and quality of experience, analytics, and optimization. So Edge is really, in nutshell, the need of the hour, and we all work together with the 3GPP I think the specs that are coming out with 3GPP and whatever the industry experts are talking together, we have to see where it falls right for every other operator. And that's how we keep discussing in these forums. And what more, we all are waiting for the MWC Barcelona to see in the last week of February what they're going to bring out. And this is the link for the agenda they've presented, high level what they're going to, you know, present there in terms of use cases and operators participating and all that. It would be very exciting. So thank you again, Kanesh, for this forum, and thank you for your time.
Brilliant. Thank you, Rita. I appreciate that. Thank you so much. Let me introduce Dr. Christina Yanzang from London, UK, to present on the 5G for digital twins and metaverse. Over to you, Dr. Christina.
Let me just share my screen. It said this will stop others share screen. Do you want to continue? Okay.
Rita, are you able to stop share? Yeah, thanks.
Can you see my screen?
Yeah.
Wonderful. Hi, everyone. I'm Dr. Christina Yanzhang, CEO and founder of the Metaverse Institute. It's really great pleasure to talk to you about how we 5G for digital twins and the Metaverse. Let's have a look at digital twins first. Sorry, I don't know what happened.
Yeah.
Yeah, let me just try again. Can you see my screen now?
Yes, yes.
Okay, give me 1 second. full screen?
No, but please carry on.
Okay. So digital twin is basically a digital representation of an intended or actual real-world physical product, system, or process that serves as the effectively digital counterpart of it for real-world purpose, such as simulation, integration, testing, monitoring, and maintenance. And the digital twin can serve like different purpose, and it's already been used in many different industries. The very start of the digital twin actually is initiated by NASA. I'm sure everyone has seen the movie Apollo 13. So behind the really interesting storyline, actually NASA was using digital twin technology to simulate what actually happened in the space shuttles in the outer space and successfully designed scenario to bring the astronauts safely back to the Earth. So that's the very beginning of the digital twin. And of course, ever since there has been lots of major development of digital twin, including the born of AutoCAD, and in 2002 we have Dr. Greaves' concept of the digital twin emerged, and of course in 2017 Gartner has listed digital twin as one of the top 10 technology trends, which makes the whole technology much more mainstream, adopting in advanced manufacturing, in aerospace, in military, in teaching, research, medical science, all kinds of different sectors. Digital twin will have a major application linked with 5G. As you can see in the chart, in many different areas, all the way from IoT, edge computing, cloud, machine learning, SDV, NFV, etc. It will really help to enhance the user case. For example, a lot of speakers already talk about the latency. So it's the same for digital twin, where we can have 5G to support near instant delivery of data from sensors to enable real-time capture and process automation, which is really convenient. And also it's really good in terms of bandwidth. So it will ensure streamlined high definition and ultra high definition videos, which we know during a lot of simulation enabled is quite important. And also it really helps to enhance the capacity. So it can be up to 1 million devices per square kilometers to allow data to be carried for many more sensors, enabling a more accurate picture of an asset to be captured. And of course, when we are running digital twin, we want to ensure the network is really reliable. So with 5G, it can ensure nearly 99.99% network reliability. So that's really helpful towards mission critical applications where failure is not tolerated. Like our previous speaker has talking about in the hospital, when you have surgeries or major operations of the patient, you want to ensure the network is absolutely 100% reliable because it's life and death issue. And of course, one of the speakers talking about mobility and transport. So in the digital twin environment, 5G can really produce seamless transfer between radio nodes up to 500 kilometers per hour. So the data availability on fast moving mobile assets on trains, cars, etc. without being dropped. So that's really good as well. And of course, since a lot of the IoT devices is powered by electricity or battery, so 5G can really help to reduce the cost of maintaining devices and improve energy efficiency. So make it really environmentally friendly. Let's also looking at the metaverse. I understand this is quite a hot topic in the past 2 years, and some people will say it's a new reality. However, the whole concept is quite, has been there for quite a while, since 1992, when author Neil Stephenson coined the term metaverse in his science fiction novel, Snow Crash. So that was 40 years ago. And the world's first metaverse is called Second Life. It was created by a San Francisco-based company called Linden Lab. So that was about nearly 20 years ago. So it's actually not new. The technology has been there for like nearly 20 years. But what happened is since Meta changed the name in 2021, and it suddenly become like a worldwide sensation. Everyone's talking about metaverse, Web3, and saying this is going to be the next big thing. So a lot of investors all jump into the space. But actually, what we are talking about metaverse now is really the second wave of adoption. So I have started the journey a little bit early in 2006. So I was doing my master dissertation at Loughborough University in the UK, looking at how to use Second Life, the world's first metaverse, to develop international strategies for university worldwide. And then I was very lucky to get a full scholarship to continue my research in the built environment, looking at how to use metaverse to simulate, augment, and optimize real-world construction engineering architectural project, which I completed in 2012. So a lot of things is a combination of digital twin in the metaverse environment and improve real world. So I think actually 5G has a very important role in that as well. Because you can see there is a lot of exciting figures predicted by many different big corporations. So PwC says the metaverse economy will be $1.5 trillion by 2030. And then McKinsey said it's 5 trillion. I think the latest figure from Citibank is that between 8 to 13 trillion. So the bigger features are very exciting. But the key issue is how we can achieve that now, all the way moving to 2030, because it's still like quite a long way away. But the most interesting thing is how do we really define the metaverse? I think many people will have many different ideas of how the metaverse should be incorporated. One of my favorite theories about the 7 layers of the metaverse, basically looking at different key components of how different technology coming together to form the next generation of the internet, which is more immersive, interactive, and intuitive. So as you can see, this big bubble, at the very core center is the IT infrastructure layer of the metaverse. So that's where 5G, Wi-Fi, cloud, and semiconductor chips, GPU, etc., coming in. So actually, 5G is at the very center of everything to do with metaverse, because without good, stable connectivity, we can't really have efficient use of the metaverse. And of course, you will have different interface, like mobile, smart glasses, wearables, haptics, gestures, voice recognition, etc. So if we have a look on the detailed feature of metaverse and how 5G ecosystem can address that, you can see it's so important to the development of metaverse. So for example, metaverse really will require ubiquitous access to the all different multiverse that films the metaverse. So there is not going to be one or a few metaverse. That's going to be many, many different metaverse. So in order to access that, we want to have quite accessible mixed reality devices to allow the user to really have the immersion experience. So 5G can really allow consistent coverage and capacity, as well as mobility support, to allow the metaverse to really allow users to experience the immersive interaction. And of course, 5G is currently pretty much global reach, so that can help to include the roaming capabilities. Another really important thing, as many speakers already touched, is about the cloud and edge cloud capability. So low latency is also quite important, as we have already discussed. And also it will really offload processing to save battery life for environment purpose. And of course, there has been lots of discussion about standardization. I think that's quite important because we don't want to have a situation where digital assets or avatars created in one metaverse cannot be moved to another metaverse, because that's going to create a lot of issues. So there has been an organization called Metaverse Standard Forum. They have already got more than 1,500 organizations working together, try to address the standardization issues of different metaverse and related technology. I think that's very important. And of course, we need to ensure we have easy access to communications and services for developers. So for 5G, it will allow early build-in of APIs into available developer platforms, as well as business logic. So I think that's all very crucial. Of course, worldwide, there has been lots of big tech giants. They are looking to deploy their own version of metaverse. I think some of the most prominent ones, as you probably have already seen, are Microsoft, Tencent, Meta, of course, Apple, Google, pretty much everyone who is like a big player in the tech space. They want to really figure out how to commercialize in the metaverse. Some are quite successful, and some are still taking a little bit longer to figure out their best way. I want to draw your attention to one of the most significant deployments, which is Microsoft, because 2 years ago, they have secured a major deal from the US Army for a very big contract valued at $21 billion to provide 120,000 HoloLens for the military to conduct like different training and real world like scenarios, which is quite significant. And this contract is going to last for 10 years. Because there has been lots of discussion saying that since the collapse of the FTX, which is a cryptocurrency exchange platform, and also everyone have seen some news that Meta has been losing a lot of money when they are trying to tap into the social and entertainment side of the metaverse. So many people are start to questioning whether or not there's still a point of putting so much research, investment, and exploration in the metaverse environment. And based on my own personal experience, starting the metaverse experience in 2006, I think it's just like any kind of technology. You will experience this kind of curve, it will go up very quickly, and everyone wants to jump in because they say this is going to be the next biggest thing, however trillion US dollars it might be, and then sort of like cooling down a little bit. But then during this cooling down period is when you have all the major enterprise solution based metaverse, they are putting huge amount of investment to try to get the basic IT infrastructure, either it's 5G or 6G or edge computing or other things, especially computing power ready. And then the consumer facing metaverse, which is represented by Meta, maybe they will start to flourish when the economy is much stronger, because everyone knows during a recession, entertaining related costs will be something all the consumers will try to cut because they are very worried about energy crisis, the rising inflation rates, which cause their food, their daily living are much more difficult. So I think the metaverse will still be there, and it will be developing quietly by some big players, especially led by like Microsoft, NVIDIA. NVIDIA is doing a lot of industrial level of digital twin, providing like major efficiency and cost reduction worldwide, covering climate change, advanced manufacturing, and simulation for preventing wildfire in America, etc. So there are lots of interesting things going on in the space. And of course, many different countries have already looking at national strategy on the metaverse, like Dubai, like China, South Korea, Japan, European Union, and the European Union is highlight that people need to be at the very center of the metaverse. So everything we do need to ensure we create a better society rather than we are become like a slave of the new technology to have more risk, especially things like online safety, data security, and privacy. I think a lot of people are quite worried about that within the metaverse environment. So the way forward, I think we have been talking a lot of beautiful things about 5G and different applications, but we shouldn't forget that out of 8 billion population of the world today, there are still 1/3 of them do not have access to the internet. So that's about 2.9 billion people around the world. They are still offline. So when we are trying to utilize the benefits of 5G and other telecommunications technologies, what can we do to really help them to ensure they are not left behind? So I think that's a very important issue. And you can see this is a global map of the digital divide we're talking about here. And you can see still a large part of Africa and Latin America, Central East Europe, etc. They are still not connected. So there is a lot of things need to be done in that kind of space. So one of the solutions provided is by Elon Musk, one of the most pioneering entrepreneurs of our time. So his solution to bridging the digital divide is using Starlink. I'm sure you probably are quite familiar with the whole concept. So basically what he has been doing since 2019 is he started to launch a large number of low Earth orbit satellites into the outer space, so they can provide much better coverage in terms of communication. And
Dr. Christina, sorry, due to the time factor, would you mind to wrap it up, please?
Yeah, it's the last slide.
Yeah.
So basically, I think he thinks this is going to help to address the digital divide, but also there are some experts worried about this could create too many walls or space jump to cause like further collision of existing satellites. So I think no technology is perfect, but the beauty is we can always figure out new solutions to make things better for our life. So I want to conclude my speech by quoting the quote from Robert Mulder. And he said, the world is changing very fast. Big will not be small anymore. It will be the fast beating the slow. So I think we can move a little bit faster and also ensure technology like 5G can help our world to become better connected. Thank you.
Great stuff, Dr. Christina. Thank you so much. Now, let me introduce Saida Haji from Aachen, Germany, to present on O-RAN scenarios based on real-life experience. Over to you.
Thanks, Ganesh. Thanks for this opportunity to talk with people and to listen to people, in terms of the different technologies. Today, I'm not going to speak about technology, but first, let me introduce myself. My name is Saida. I'm based in Germany, Aachen. Originally, I'm from Azerbaijan. And I'm doing telecommunication and different technology domains, dealing with about 15 years. And last 4 years, I'm doing Open RAN and cloudifications and the automation solutions for Open RAN environment. So today, I'm not going to talk about this technology itself, but I would like really to talk about this realities of the Open RAN and just the articles and a lot of talks about Open RAN, just people are talking, does really it change the game, and is it really worth it to deploy? Is it really worth it to have it in our network? So this kind of a lot of fancy talks about the Open RAN TCOs that gaining that much, this much, and some of the community of criticizing the solution itself. However, I mean, just unfortunately, less people are talking about the realities. So what are the Open RAN realities? Where we need to start? Which kind of things that operators need to consider before they making decision to go with the Open RAN. So do they have visionary approach? Do they have proper strategy, or it's just to follow the trend? I mean, do they just need to reduce the cost to do more innovation and increase the network flexibility in terms of to manage the performance and to avoid the single vendor dependency and destroy the comfort zone, because technology doesn't demand that. Technology demands more. You cannot just operate your network for long years and being dependent on one single vendor and your employees doing nothing but just controlling them. so technology world is not like this. We should always do some revolution. We should always do some changes. We cannot stop anywhere and just hand over our network to the one single vendor to operate that. And we should go with more innovation. And so that's why so second box we are talking about, we are ready for that innovation or not. Do we have right ecosystem, strong infrastructure, cloud infrastructure, edge locations? So do we have a right mindset and resources to have the solution, operant solution in place? And we know who is our partner, and their solution is suitable for our architecture or not. So this kind of things we need to consider, operators should consider from the top, from the beginning. And also they should understand their pain points in terms of analyze and just, the challenge, the solution provider for the automation use cases. Because in Open RAN, you have 1,000 chances, unlimited chances to automate your network elements. SMO and orchestration is the main part and main weapon of Open RAN, which operators should understand that, and they should challenge solution providers. For example, in mass rollouts, it can be challenging because it is multi-vendor environment. You have a lot of network elements to deploy in the field, in the lab. So in that case, you should have, for example, zero-touch provisioning in order to onboard your DU, CU, and RU with that approach, with that methodology. For example, in 5G mass rollouts, it will be really useful, and or to deploy your cloud components with automatic installation, which calls BMAS, or troubleshooting your network elements with self-healing. So there are a lot of automation use cases that you should understand your pain points in order to demand it from your solution provider. And another thing that we're always facing as a challenge as operators, they have concern to invest or not to invest, wait and see. This is also kind of another bottleneck to allow Open RAN to move forward, because we always need to give a chance to new technologies, as I said, in order to bring more innovation. So manage multi-vendor ecosystem and race it, that must come from the beginning, and you should have a very clear vision in order to manage multi-vendor governance. Because most operators and solution providers, they focus mainly technology, but governance, communication, reporting is the most important. Planning is the most important. If you are failing in governance, you're going to fail in entire project, and not to get just satisfied with the results at the end. And ORAN strategy, ORAN architecture must be captured very carefully. You should understand who is going to provide what, who is going to be responsible, accountable for which part of this streams, because there are a lot of things of starting from the hardware provision, physical installation, integration, testing, and so these kind of just responsibilities must be divided and separated carefully at the beginning, because most time, based on my experience of managing multiple projects, there are always some kind of concerns and issues that raised during the implementation. So these are the main factors that we need to consider at the beginning when we decide to move with Open RAN. So about other realities and challenges, if you allow me to talk about. So yes, Open RAN is new kind of methodology in order to deploy your 4G and 5G with that approach. It is everyone is talking that it is not mature yet, but I don't consider it's not technology itself, because technology is kind of 2+2. All the specifications are in place. This is up to us, up to human, to make a decision how to make them work together, how to kind of adopt them, and how to integrate them. So this is we have to be a bit mature in that, not technology itself. So starting from the planning, for example, if we are not good in just simply say in a site survey, we are not considering all the details properly, then we are going to fail in hardware planning, and we are going to fail in hardware onboarding. And also regulation is a main aspect of Open RAN to start the project, because most time government authorities, they are not aware about this solution, and we have to provide a lot of kind of statements, reporting, and a lot of things to convince them about the technology, and it is very time consuming, and that's why we have to consider it in the planning phase, as well as IoT and RCT that need to be conducted by solution providers on time, because of it is very important from IoT RCT perspective that your devices are talking to each other. There is a seamless connection in place. So, and also as well as the test MOPs that are also important to capture from the beginning. Even very basic test cases, even you are rely on yourself as a system integrator, that you are professional, you can do everything smoothly, but however, all these test MOPs must be captured properly. If you avoid this kind of poor planning, in that case, you're going to not to have network related issues. Just mainly we are seeing in kind of in software part, when you don't have compatible software in terms of, and especially in radio software, because also required proper planning from the beginning in order you have compatible software and stable software. And also interoperability, that also part of the discussion. Unfortunately, interoperability, it's still there. And why? Because solution providers always coming with the solution and saying that it is pre-validated. And yes, this commitment is there and it's a reality, but however, interoperability must be part of every project, because you need to match that solution to the operator architecture, and this operator architecture must recognize those devices, and it must, and especially in IP side, in transport side, because there is always inconsistency in transport, as it was mentioned earlier, that transport is very critical, and it is always device specific, that you need to find out why those packet losses that happening. So interoperability must be separate phase of the every project, like a planning, like a, I don't know, testing, integration. So we shouldn't commit that it is pre-validated and no need interoperability in the customer premises, but we have to. And also security concerns are there, which we have a solutions, of course. Automated security policy enforcement must be there for every clusters. And other than this, you can deploy network slicing solutions in order to isolate every slice to protect your network from the cyber attacks. So this is a bit another topic that we can discuss maybe in other sessions about this technology itself, to deep dive in technology. But other issues like we are facing in end-to-end test cases and end-to-end test execution in customer premises, because the challenges that we are facing, just like a basic things like a VPN connections, it is always challenging to allow that a customer to allow a solution provider to connect and to work, because you have a lot of streams in order to work for Open RAN, starting from RAN, cloud, core for IP, automation, FCAPS. So those streams everyone need to connect through VPN and work on it. And sometimes also the challenges with limited SIM cards and the issues on core side that impacting the call tests. I mean, the issues not only on the solution provider sides, also in the customer sides. I know that it is because of this new technology, and we need time to, just to understand it well, not to have such kind of mistakes and such kind of issues in the future. And also, we have to be very careful in hardware commitments, because hardware commitments sometimes it's coming just like based on the contract or loan. We have to be very careful in providing those commitments, because the priorities can be changed and stock availability issues can be there, and this is also part of the planning. And everything is in Open RAN. Like I can say that most things are part of the planning, that we have to be careful in order not to fail in implementation. And the standardization also is there. We are still slow in standardization because of the agreement among the vendors and different organizations, and also compatibility with the existing systems are there still. So this standardization must be there in order to move with the same standard setup, in order to have a successful Open RAN pilots or Open RAN deployments in commercial launch. So this kind of the criterias and challenges are still there, but we are working day by day to improve it, to make it even more better, and to bring this innovation. And I wish one day all operators start to deploy the network with the Open RAN approach. Thank you. Thanks for listening to me. If any questions, I'm ready to answer. Thank you.
Great stuff, Saida. Thank you so much. I appreciate that. Let me introduce Nav Pokela from Sydney, Australia, to present on the 5G Open RAN.
Hi, everyone. Thanks for presenting the topic, Saida. It's just a follow-on from what you presented there. So let me share my screen. Can you see my screen?
Yes, sir.
All right, excellent. Okay, so the 5G Open RAN. So I'll be presenting on a very similar topic, but probably diving a bit more on the technology side. The customer that I work for in Australia, Optus, we have a pretty traditional RAN approach. It's a distributed RAN architecture. Everything from baseband to radio to antenna is following the traditional RAN models. But we have been, at least our solution sales teams have been pitching Open RAN to them in those discussions. But as Saida mentioned, the adoption needs to match the customer sentiment and their approach to innovation, and also capital expenditure. So some of which have been a bit limited as of recent days for Optus, which is my customer. Open RAN is also a new domain for myself. It's something, say, I'm interested to understand better. But I think across the globe, this is what we're really trying to do, is understand what Open RAN is, and some of those controversial points, trying to make sense out of what all the discussions that are happening and the hype as well. So in my presentation, I'll be talking about the O-RAN Alliance, who they are, the O-RAN landscape, some of the architectural differences as well that are coming in, and set definitions of O-RAN. Sometimes we get confused with those. Some of the drivers and business objectives, benefits, high-level architecture, challenges, and then I'll try and conclude. So obviously, if we look at the entirety of the landscape, we've got many telecommunication standards bodies, and O-RAN is one of them. 3GPP have been around forever. Since the, I guess, 3G days, release 15, we've been defining standards. Now with O-RAN Alliance is the alliance behind Open RAN. So founded in June 2018. I'll use a laser pointer. Founded in 2018, defining the Open RAN architecture in parallel to 3GPP. So obviously 3GPP being the primary body, and O-RAN Alliance working quite closely with them to put the standards up and to define them for vendors and operators to work with in commercial deployments. But as you can see, there are other standards as well in the world of telecoms, and which we've got here, but where our focus is on the O-RAN Alliance. Now, what the Alliance is doing is they're trying to understand how we can make RAN as open as possible in terms of disaggregation, in terms of interoperability, introducing different vendors, and trying to make them work together on specific Open RAN interfaces. So some of those interfaces can include high level and low layer splits as well. So layer 2 to layer 3 RAN protocols being on the higher layer side, and then lower level being the physical layer, the frontal, the radio side, the modulation and radio side. So we've got we call the Open RAN LLS. We've got that lower level split. And with machine learning and AI being so much talked about in terms of how that would shape the future in telecommunications technology, the whole automation side is coming from these APIs that are getting defined, these machine learning capabilities and AI capabilities coming into the mix. For example, there's a lot of talk on the AI-based air interface in, say, 6G that's going to come on. And if we go towards this direction, then we got to obviously start adapting these technologies that are very much IT-based, now also in the cores, in the mobile cores, like 5G core, and bringing it onto the RAN side. With the RAN being one of the higher revenue generating parts of a mobile network, it's about how do we do a RAN architecture evolution and shape it. But yeah, there are still a lot of operators who prefer the more traditional models because they're just used to it, and sometimes this innovation cycle can be very disruptive for some. So like in my current operator, we still have that traditional architectural approach to RAN hardware, but the sales team is pushing pretty hard. So obviously, hardware to software disaggregation is one of the objectives. How do we disaggregate software and hardware? The whole concept of VNFs and white label hardware. So this white label term is already there in IP networking, where you have like Google has their switches, white switches. So it's sort of coming into telecoms when we're talking about white label hardware. And who O-RAN Alliances is basically they're leading the industry towards an open, interoperable interfaces and RAN virtualizations. And we've got some founding members, including say AT&T in the US. A lot of the board members are pushing hard, and they're early adopters. But then we also have the more traditional-minded operators who don't want to go in this direction because they're concerned about the hype and what that might bring on to the mix for them. Now, strictly talking about definitions, Open RAN is an industry term for Open Radio Access Network Architecture with open interoperable interfaces and big data and AI enabled. So this is when we're talking about Open RAN, it's specifically the technology Open RAN and the architecture. Open RAN without a space does refer to this telecom infra project, which focuses on early technology trials on the Open RAN ecosystem. Much less used because not many people know about this group. But O-RAN specifically, O-RAN is like talking about the alliance. So it's talking about the standards body specifically, and not the actual architecture of the technology, or not the actual technology itself, like Open RAN. And O-RAN, it's very interchangeably used. Sometimes people are referring to it as the O-RAN Alliance, and sometimes Open RAN, the technology. And being careful about and understanding architecturally what are the differences between some of these other RAN architectures that are coming in. Obviously, we hear a lot about cloud RAN and virtual RAN. and then also Open RAN. So then how do we really tell the difference? It's very confusing to read these words and understand like what is the real difference here. So with Open RAN, industry term is obviously for the open radio network access architecture, where you have disaggregation between hardware and software. You've got multiple RAN vendors who can work together, having that interoperability. We know what ORAN is, the alliance. And then Cloud RAN, the word itself is specifically talking about the cloud native software solution, where RAN applications are run on container-based functions, so over commercial off-the-shelf hardware. So then that whole use of the word Cloud RAN is coming from how it's cloud native, can be run on cloud infrastructure, et cetera, things along those lines. And then virtual RAN is, again, coming to network function virtualization, separation of the CU and DU. And so it's, I mean, these things, in terms of the architecture itself, they're very, very similar, very fine print differences with what it means to, because Cloud RAN and Open RAN sort of come together as a package. Because when you're deploying something, it probably is on cloud native software and it's open. So then you have both. So yeah, but it's important to understand the intricate differences sometimes of what this means. Now, business objectives are pretty much trying to solve for the operator business challenges. For example, surging bandwidth demand. We're always trying to move towards millimeter wave spectrum, trying to meet that bandwidth demand for the operator. Trying to always have competition with other competitors and rivals, and prepare for a future 5G network. Cost per bit, obviously, if we're talking about return on investment for any operator, cost per bit is very important to them because it needs to reduce. As you have more bandwidth, more capacity, your cost per bit should go down. And I mean, your revenue, it's one of your revenue generators. And also there's the adoption of SCN and NFV. Again, very traditional, very IT-based technologies now coming to the RAN. So it is a little bit scary for a lot of people to then understand how this is applicable in the RAN world, which has been so from 2G days, 3G, 4G, very different from what some of these say what ORAN is trying to do here. So it is a shock for a lot of people to understand how the technology is evolving so fast, where in the past it's been a little bit more stable as we jumped from the generations of mobile technology. So obviously largely remain untouched, which is surprising given that majority of the CapEx and OpEx and buildings and managing networks is the RAN. So that's where the majority of the TCO comes. And when coming to objectives, we are revolutionizing, bringing these cloud scale economies into scale, using this off-the-shelf hardware, modularizing the software, then doing a lot of automation and orchestration, very much IT-based approach, and a very agile approach to how you do things. So this is where the agility comes in, very much DevOps-based culture, how the operator tunes their network, without having to wait for vendors to deliver features. So traditionally, you'll have an operator, you'll have a vendor, say Ericsson, we'll be working hand in hand, deploying onboarding hardware, software features into the network. But here it's really not depending on that single vendor model. How do we have an inter-vendor world?
Hi, Nav. Due to the time limitation, it's already 10 minutes. Would you be able to wrap it up?
Yeah, sure. Got benefits, which I've sort of talked about. I'll just move on to quickly the architecture. So the architecture looks something like this. You've got an open frontal between the RU and DU, which is the radio unit and distributed unit. Then your centralized unit can be split into control plane and user plane. Going into the core, it is a little bit more complex when you actually look at it with interface to interface. Like some of these interfaces like include O1, A1, O2, which are automation-based interfaces, and then standard 3GPP interfaces as well. Like we're all familiar with X2 and XN, which has been around since 4G, 5G. I won't go too deep into this because this will take a while to go through, but I'll just quickly jump into the challenges. So the major challenges are system integration. How do we work on projects where the different OEMs, vendors can work together to build up these solutions for operators? Because you need a lot of integration. Things won't work easily because, as was highlighted before, the transport network and the how specific vendors do things would be very different. Even the software that's running on the baseband is very different. Even the software lifecycle management very much more complicated than your traditional GA-based general availability software, which has its own release life cycles, which we did traditionally. ORAN software life cycle management is a little bit different. Also measuring system performance, because now you're not depending on a specific vendor for measuring performance. So it's not like a proprietary thing where you have counters which you can measure for KPI management, but it's very much how do we ensure that features can be deployed and performance can be measured easily, as well as the assurance of security as well. How do we ensure that we don't have security breaches and issues there? And then finally, to conclude, we do have a lot of traction in ORAN. There are a lot of drivers that are bringing this up, a lot of early adopters in the world, like AT&T. And it's a whole innovation cycle that's going on right now. And let's see where this technology goes and where it takes us. Thank you.
Thank you. Now, brilliant. That was a great presentation. Appreciate that. Let me introduce Tirawat Botikul from Bangkok, Thailand, to speak on 5G mission critical communication services in Thailand. Over to you, Tirawat.
Okay, thank you. Okay, let me share. Okay, so basically today I'm not talking about too much thing or practical, but more on like the way that Thailand like implement the so-called mission critical communication via 4G and 5G. Okay, so basically when we talk about the MC or mission critical services in 3GPP actually starts since release 13. Okay, with MCPTT, Mission Critical Put to Talk. It's basically they bring in the traditional put to talk services of the frontliner, the voice communication into the broadband era. So in Thailand, we start quite quick, actually quite early, because our first broadband 3GPP based MCPTT starts since 2016 with the police network, right? We implement the private network for the LTE private network to provide these MCPTT services in 2016 for almost 50,000 police officers. So it's quite early, actually. It's just a year or talking about the 3GPP standardized network. We are one of the first network in the world, together with the FirstNet in US or the ESN in UK or even the SafeNet in the Korea. Okay, as of today, the 3GPP already go to release 18 with the 5G mission critical, and this one is like the services that provide similar. I mean, they combine together the mission critical kind of requirement to the multimedia services, and also integrated with the railway requirement with FIMCS. So basically, if for the later times, I would like to talk also about how mission critical MC services really used in the railway business. Okay. In Thailand, the mission critical communication is still dominated by the narrowband from the analog time, VHF, USF until the TETRA and P25. Actually, you kind of mix between European and the US standard, depending on the user. It's still dominated by the narrowband, the voice only, but for the broadband side, we still even we start early, but we not really grow the broadband MC subscriber that fast. So we still have like around 50,000 subscribers, while the narrowband is like 200,000 subscribers already. So in terms of network, is still dominated by, in terms of sector, is still dominated by the public safety sector, like the police and the Ministry of Interior. They have their own network. The Thai police have their own private network, but for the Ministry of Interior, they use the over LTE network, over cellular network since 2019. This is OTT model, but not really 3GPP compliant. Talking about the main driver in recent year is more on the transition from the narrowband to the broadband as a main driver, but the main issue of the broadband adoption in Thailand is the spectrum issue, because till now in Thailand, the regulator still not grant any private broadband network to any sector but the public safety. So that's why it's still the broadband MC is still limited in public sector. But what we can see now is like we see the requirement and improvement also from the transportation, utilities, and healthcare, which I will give a bit more information later. So in terms of trend in industry, because 5G network, 5G commercial network in Thailand is quite developed. Actually, we have like almost, let's say, almost 100% coverage for the 5G in Thailand with 3 mobile operators. So, and 5G is kind of government, is the Thai government key performance indicator for many agencies. So basically, for the government project, if you put the name of 5G, you get a lot of promotion from the government. And also the carrier is trying to do a lot on the 5G to be business services. Also the IoT and M2M, because right now the connected camera, the AI camera is really important for Thai agency in applicable public safety sector. So we see a lot of use case on the MC data services for IoT and machine to machine communication. Another area that we also increase the usage of mission critical, I mean the standard one, that the most secure one, is about the importance of the cybersecurity is increasing. And also for business side, they're also looking for the new use cases, application, and the new type of device like the body one camera. And government and the creation policy is also helping to drive this mission critical in Thailand. One thing we can see that before the spectrum is only available for public safety, we even call it PPDR, right? Kind of spectrum, but now the regulator is trying to put more use cases on the assigned spectrum, and also planning for the another new dedicated spectrum for some specific sector, actually the transportation sector. Okay, and the use of MC services over the public network or carrier network, it become more accepted, because we can see, actually I involved in many projects of the MC service over cellular for the set enterprise security and even public safety. So what we try to do here, we see the growth in the market in terms of actually from transition from the narrowband to broadband. And the 5G, even as I mentioned earlier, that the 5G, the 3GPP standardized 5G mission critical services is not really is still in the paper and not really implement anywhere in the world. But actually, we look at it as opportunity to bring into Thailand market together with the, because it will definitely come with the capability of IoT, M2M, and also the cybersecurity. Okay. So just to summarize quickly about today. Actually, today, the main idea of this topic is like mission critical is something that not really focused for the 5G application development, but in this year in Thailand we see some of the big development in terms of government regulator spectrum allocation that may happen within this year, and also we see that many agencies in Thailand, actually the transportation, utilities, and public safety, they want to evolve their current narrowband mission critical communication into broadband, and the 5G and C services will be the key of the development. Even it will start first with over the public cellular network, but hopefully after the regulator allocate more private spectrum to specific industry, we will see a lot more development in this year. Okay, this is all of my presentation. Yep.
Thank you so much, Tiravat. Really appreciate that. Now let's get to our last speaker. I would like to introduce John Herman from Richmond, Virginia, USA, to present on an application STP using MCN and private network. Over to you, John.
All right, thank you very much. I appreciate being here today and being able to talk, and especially to listen to everybody. It's been a fantastic conversation. We've heard about, devices and applications that require 5G. We've heard about radio technology, network transport, Met Cloud, and also the importance of security planning and governance. And so what I'm going to do today is actually take a step further into the cloud, a little bit away from the radio network, and talk about how we actually integrate all this to the rest of the world. I'm with a company by the name of 3Nets. We're a startup, and essentially we are a company that is addressing a lot of specific challenges of application infrastructure delivery across multi-cloud and private cloud platforms, which of course includes 5G edge clouds. And really, to explain how we got here, I like to always throw a little history in, because I'm a little bit, I've got some experience, and I like to kind of go back and see where things have been. And so really, a lot of the major cloud vendors, introduced products back around 2010, 2011, and most of them came online at that point in time. But, there was a lot of skepticism within enterprises. There were security issues, there were pricing issues, data privacy issues. And so, there was a lot of skepticism at the time to move to the cloud. Probably the killer app 10 years ago and moving to the cloud was the DevOps environment. It was a perfect environment for cloud computing. You could turn up resources real quick. You could get to work on your project real quick. And, whether the project moved forward or whether it failed, at the end of the DevOps cycle, you could just turn off all of your computing, and you wouldn't be left with a closet full of equipment waiting to be repurposed or potentially even obsolete at that point in time. And so really the killer app, 10 years ago was the DevOps environment. And, slowly storage and even some computing moved to the cloud. But for the most part, the majority of IT at that time was still in the enterprise data center. And, all that really started changing around 2015 when a lot of the business school research started coming out about, the term digital transformation. I think everybody's heard of that. And so digital transformation became a huge force within all enterprise businesses, less than 10 years ago. And essentially what all the research coming out of the business schools around the world was saying is, you either need to digitize and automate your business, or you're going to become extinct. And so, suddenly IT shops that were kind of pushed to the forefront of business. And really what you've seen since then is just rapid expansion of cloud adoption by all these companies that are trying to quickly move to the cloud. Small companies like ourselves, we actually have no IT whatsoever. Everything is done in the cloud, outside of the laptops that all of us own. Large firms are, slowly, repurposing applications. They're taking old applications and moving them to a microservices environment. And, even things to kind of show how far things have come, even financial firms, banks have moved into the cloud. And so that's, such a huge change in perception in just, a matter of 10 years. So, I find that pretty amazing. So, but, going to the cloud has not come without a lot of challenges. And so, moving to the cloud, there are, no cloud, the biggest issue is no two cloud providers are alike, right? Each one has its own different definition of computing instance. They have different security constructs. They have different networking constructs. The billing can be slightly different. And, as you can imagine, you move out of a nice private data center where you were the sole autonomous individual in charge of the data center. Now you're moving into one cloud, let alone two, where you're introducing all this new technology, all these different underlying constructs. Moving to the cloud has not been difficult, and there have been quite a few challenges associated with this migration to cloud computing. And one of the things I like to always talk about, again, because none of the cloud providers are alike, to kind of give you some perspective here, it's if you think about internet access, when you purchase internet access, you as a consumer are gaining the benefit of thousands of peering agreements that take place in the background. And these are agreements between all the different internet providers globally to, push packets back and forth, maintain some type of regulation and governance amongst each other, and actually be good neighbors with each other. And so in the cloud, the cloud providers don't do that. And so you, or the customers themselves, have to ultimately become a peering company. They need to bring different cloud providers together. They need to kind of stitch together the actual constructs and make it work. And that's very difficult. And it's difficult for a number of reasons. Each cloud provider, you need to understand their interfaces and their constructs. And so there's this concept known as the skills gap that's out there. And that, if I'm working with multiple cloud providers, I need experts in those multiple cloud providers that know how to navigate the different the service options that they have, and know the underlying differences between those service options. And then there's still the security profile, right? You're moving from beyond a single brick and mortar data center out into the cloud. Your data is spread out all over the place. And so now there's security issues you need to think about. And, and again, this is all extremely difficult to manage, not just day one and getting it up and running, but ongoing. With new microservices, you now have workloads that are spread all over the place. There's a lot of concern with, distributing workloads and the placement of them to make sure that the application stays and operates properly, and that, of course, the end user experience is not undermined by the actual deployment. But all these challenges, right? All these challenges being what they are, it hasn't stopped the appetite for more cloud services. Customers are looking for more cloud services. They're, distributing their applications using Kubernetes. And, now we're also hearing about artificial intelligence being added in. And so, we expect the whole cloud infrastructure and application environment to continue to move forward at a rapid pace. So, and just kind of one last thing about that, just to give you a feel for how far we've come in the past decade. A decade ago, as I was mentioning, customers were having trouble justifying moving to the cloud, and they only had a few applications that they wanted to move to the cloud. Well, if you've read any periodicals in 2023, everything now is about cloud cost. The cloud providers have done a fantastic job at making access to computing and services simple, right? And so, you've got large organizations, and, there was a discussion earlier about governance and that sort of thing. A lot of large organizations have moved into the cloud, and they've, turned everybody loose. but being that these cloud providers have allowed such easy access to these services, customers that have gone into the cloud without the governance are being hit with huge cloud bills now. So we've gone, 10 years ago from, being afraid to move to the cloud to this year where, or even the past few years, especially with COVID, of everybody moving so fast to the cloud that they've done so, without the proper governance to manage costs and manage process and ensure processes are fully utilized and that there aren't ghost processes that are just sitting out there, racking up charges. And so, of course, with all of this comes challenge, right? And with these challenges come a lot of opportunities, and that's really where 3nets comes in. And so, what 3nets is doing is developing a service delivery platform that really focuses on this application infrastructure across multi-cloud environments and private cloud environments. And so we do this by, simplifying the service delivery across the multiple clouds, and obtaining much needed end-to-end visibility and actionable operational intelligence for ongoing operations, automating ongoing networking flows, whether it be scaling network, adding new locations, deploying on a completely different cloud, optimizing application performance, whether it be for the actual performance of the application itself, bringing high availability across multiple clouds, which is important, and ensuring that the user experience is preserved and it isn't undermined by migrating workloads. And finally, of course, there's securing data in motion. So you've got multiple clouds, you've got a platform that seamlessly secures data as it moves from one cloud provider to another, and giving customers that comfortability that they can go ahead and do this without bringing in multiple security experts every time they spin up a new cloud instance. So finally, so what does that mean? So essentially what our platform is and how we get here is we've developed our own modular software stack. And what this software stack allows us to do is deploy instances on every cloud and make everything look the same. So, somebody moving into a multiple cloud environment now has, this advanced ability to, bring up one service in Microsoft, a different one in Google, a different one in Amazon, while also ensuring that the multiple edge clouds that are coming online can also participate in this unified VPC and essentially simplify the infrastructure environment and allow them to deploy applications efficiently, allow them to ensure that they're available across multiple clouds, because as much as the clouds are there, they also fail just like any other piece of equipment that's out there. So you need to ensure that there's availability across them. And also bringing the automated scalability and elasticity in the connectivity. So you're not necessarily always bringing network operations people to the table to address day-to-day needs, and allows them to move on and do more important skills-based workloads that benefit the business operations versus the day-to-day moves as and changes that have become quite a burden. And so what does this mean for service providers? So for service providers that are out there, it's really going to be important not to just operate within your own cloud, but to be able to expand from your cloud to those other clouds, because you cannot touch everybody out there at any one time. You're not going to be able to be the edge computing instance globally. And so it's going to be extremely important for service providers to offer services that allow their customers on their network to also reach, locations and customers and computing instance on other networks. It's all, it's going to be important to allow those that network to be secure, to segment the data so that different workloads can be protected from each other, to ensure that there's, high availability across the multiple clouds, as well as, disaster recovery capabilities as well. And Kanesh, I hope I've stayed within my 10 minutes today. So I really appreciate the opportunity to chat with everyone today. And, if anyone's interested in our technology, please, follow us on LinkedIn.
Great stuff, John. Thank you so much. Let's have a quick 5 to 10 minutes Q&A session among the speakers. If you could able to switch on your cameras, would be good. Are you able to stop share? Yep. John, are you able to stop share?
Oh, sorry about that.
Okay, great stuff. So let's do a quick brainstorming. You know, if any speakers have any questions among the speakers, we can just have a nice friendly chat. Maybe I can start first from my side. As you are aware, that I think most recently, about 2 weeks ago, the findings from the research firm Del Oro Group have mentioned that currently there's only 39 mobile network operators have deployed 5G standalone, and more than 200 mobile operators have actually deployed the non-standalone. And there are still more than 700 LTE mobile network operators still operating with the 4G LTE. So now the question is, we have these huge developments that's going on in the vendor segment, developing the 5G equipment, infra, private networks, O-RAN, and all this stuff. A lot of huge hypes is going on. And on the other side, in terms of the applications, you could be able to see the artificial intelligence, machine learning, the new stuff, Web 3.0 is going on, metaverse, AR, VR, and all this demand of applications, you know, for those, you know, low latency and high bandwidth demand requirements, definitely you need a 5G standalone, because only 5G standalone with those features can able to support the high bandwidth, low latency, high speed, and all that stuff. So how are we going to cater for this 2023? I just want to know the opinion from any of the speakers. What is your feel in this kind of situation?
I can take a stab, finish.
Yeah, sure.
I think hearing everybody here, it was definitely enriching experience to know different aspects of the same technology. Coming to a point, I think you are so right. Like, we all are so versed in the terminology and we can speak out all the verbs very well for the 5G, but the major point which I feel in my reading is that, you know, the investment is a little higher than the revenue at this moment, because the technology has a lot of potential, but where is the actual money, right? That's where operators are struggling, like, you know, setting up the cloud or keeping it at the edge. And then, as Christina said, getting those metaverse type of use cases for the youth, right? Mostly people are attracted that way, augmented reality, but laying out the 5G ground from RAN to transport to core is just like, you know, overall, it's just like doing it a clean slate and then bringing it up as a standalone. But looks like the future is really, the near future, I would say, is really the combination of 4G and 5G, right? So it has to be a mix, because operator is getting a lot of time at this moment, in the sense that they are in the spot. They can do much more they were able to do in 4G because of all API models, right? And they have more control over their own networks rather than just the you know, OTTs and all. But I feel that developing the core and really focusing on the 5G main points, which are the exposure functionality and the edge, would definitely give a lot of revenue, and in the mix of IoT, because we all are getting into the smart mode of living. And when we are going to live smartly, then we will need the technology to support us. So yes, I think we are going forward, but really need to find where is the right rainbow point to get the revenue out of it.
Thank you, Rita.
Thank you. Thank you.
Anyone wants to add anything on this? Yeah, please.
Sorry. I think, I mean, we talk a lot about 5G, but we also know worldwide there's already big race about 6G that has been taking place in recent years. So I think people are really looking at huge investments into major technology infrastructure to ensure we are better connected, much more secured, and also there will be really reliable technology infrastructure that's happening across all kinds of different technology platforms, whether or not it's telecommunication or computing power. I mean, there has been lots of developments about quantum computing around the world, because I mean, for the metaverse and Web3, we still need at least another 1,000 times computing power to really support all kinds of different simulations for digital twin and different industrial enterprise solutions. So that's not yet available. And I think it probably will take another 5 years minimum, up to 10 years, to have all the many different ecosystems really much more matured. And then maybe at that time, a lot of the issues we're talking about today are interoperability, standardization, online safety, etc. will be solved.
I agree with you, Dr. Christina. I think 6G will be very relevant towards to the metaverse in particularly, because it, or double or triple times of what 5G can able to deliver, 6G can able. But however, we realize that the mobile operators are still taking a one step back, where they are still considering on the 5G standalone deployment. So it could be the cost of it, due to the infra. We only have 39 around the world. It's a very low volume, and if this thing will takes time, just imagine the 60. There will be a big question whether the mobile operators are ready or not even in the next 5 to 10 years. So is this the cost is the major issue right now, or is there any other ways that we can able to tackle it? I mean, we hope that 2023 there will be more operators will consider to deploy the standalone, because then only you can able to enjoy, to witness or to experience the real 5G content, speed, low latency, bandwidth stuff and all that stuff. Yeah. So yeah. Anyone else wants to add on?
Kanish, I just want to bring in a couple of points here. Like when you talk about 5G, or for that matter, any new technology, the adoption is quite different from market to market. And I actually come from a developing economy, an economy with a lot of financial challenges, political challenges, etc. So as we move forward, the investments from operators towards 5G and newer technologies really depend on their market situation also. For example, in Sri Lanka, the 5G spectrum is not yet auctioned. So we have certain uncertainties as to how you sort of take your investment decisions to for example, to build a transport network, for example, to support 5G. With a lot of uncertainties. So I think we have similar markets out there, and most of these operators are brownfield. I think that's the main reason that you have a lot of non-standalone deployment versus standalone. So they have already made investments on 2G, 3G, 4G. Like for example, in Sri Lanka, we have 2G, 3G, 4G, and 4G we have fixed and mobile 2 versions. So we have huge investments already made in deploying wireless type of mobile or fixed broadband services. So most of the operators would want to leverage those investments and really be cautious in constrained situations to make any 5G investment. And that is why most of them I see take an approach for if you take the transport network development, a bottom-up approach. You anyway need the capacities and the footprint. So deploy your forwarding plane or data plane, but anything additional like your machine learning, AI, analytics, orchestration, control, service orchestration, network orchestration, automation, everything comes as need basis. So with constraints, operators would adapt to these type of investment decisions. So that's the point I just wanted to bring in.
I have a big question here. I think you are right. Do you think that the mobile operators might want to consider by having a non-standalone and then slowly migrating to a 6G network? Do you think it may happen?
For me, 6G will take a long time.
Yeah, I think
yeah,
too long.
it's all about, Ganesh. I think it's all about our investments. So
Yeah.
who's going to pay for this?
That's right.
Right. So research is one thing. I see a lot of research is happening on the 6G side, which is good. But when you really want to take it to masses, who's going to invest on deploying these technologies is the real challenge.
Right.
Could I chip in there?
Anyone wants to add anything or have any questions on any related matters? Yes.
Yeah, I'd just like to add that, even here in the States, the bigger companies that have deployed 5G and went all in are, receiving a lot of pressure from Wall Street because they're not seeing the revenues yet with the, a lot of the applications that we spoke about today. So, they're a little bit ahead in terms of the deployment, but are still waiting for some of these revenue generating IoT type of applications to develop with the enterprises. So I think we'll see that happen here in the next few years.
That's for sure, John. In fact, South Korea was one of the pioneer in terms of deployment of 5G, and they're willing to take risk of spending 10 billion USD, knowing that they will get a break even in the third or fourth year. They took the challenge, and so they were running loss. They never got much, but yet they had a huge GB usage from the consumers, right? Because Korea was the only country who was very much consumer driven rather than enterprise or industry driven. Because 5G was built just purely for industry driven rather than the consumers. Because we know that consumer will never consume that huge amount of data. Maybe on certain specific markets, Korea, yes, the AR, VR was really exploding, Pokemon was the original to start, right? And that really kicked off with other gaming services. So yeah, like what their monthly usage, like what average 28 to 35 GB data per month, right? So I think yeah, I think there's a lot more to wait, and only few market will willingly to spend that huge amount of infra with that huge cost. Dr. Christina, you want to add something? So yeah, if anyone have any questions, I think it's a long day, a long time, 2.5 hours. So I don't want to hold you any longer. Thank you so much. I really appreciate for your time, for your support. This will be so useful. We will upload this on our YouTube channel in a couple of hours time. Let's keep in touch. We never know, we will meet again sooner or later. Thank you so much. And I really appreciate for your time. Have a nice day.
Thank
Thanks,
you.
Ganesh.
Have a nice day.
Thank you.
Thank you.
Thank you all.
Thanks, everyone.
Yeah.